Ohm's Law. What is it and how to use it? So very simply, Ohm's Law is a mathematical law that defines the relationship between voltage, current, and power. Now, Ohm's Law does a lot more than define that particular relationship. But for the purposes of this video, we're going to discuss voltage, expressed in volts, power expressed in watts, and current expressed in amps, and the relationship between those three electrical elements. So one of the beautiful things about Ohm's Law, it works for AC and DC, alternating current and direct current. The same law, the same calculations, AC or DC. So Ohm's Law, very complex formula for lots of different aspects, but we are going to specifically focus on the volts, watts, and amps relationship, which is watts equals volts times amps. So let's look at a real simple example of Ohm's Law. We'll take an automobile, which has a 12-volt battery, 12-volt electrical system, and we are going to plug a load. We call any device that consumes electricity a load, and we're going to plug that into the cigarette lighter, and let's say it's a computer device and it's rated at 24 watts. So now we want Ohm's Law to calculate for us the amount of current draw, or the amps in this particular scenario. So it's very simple. It's 24 watts divided by 12 volts, and the answer is 2 amps. Okay, so let's talk about some practical uses for Ohm's Law, especially in the pump world. So one way to use Ohm's Law is to say you have a simple power supply and a simple pump, very basic. Power supply and pump, and you want to put a fuse in between there to protect your pump. So you would use Ohm's Law to determine the size of that fuse. Another very practical use for Ohm's Law is, let's say you have the pump and you're trying to figure out what size power supply to use. Again, very common practical use for Ohm's Law. And lastly, you have a pump and you are trying to use that in conjunction with a solar panel. And again, the solar panel would be much like a power supply, but you could use Ohm's Law to help you select the proper size solar panel. So now, in order to apply Ohm's Law in some real practical situations, it's really important to note that not all devices are rated the exact same way. So what does that mean? So light bulbs, predominantly rated in watts. Fuses, in amps. Solar panels, again in wattage. And power supplies, interestingly enough, all three attributes are normally given: the voltage, the wattage, and the amp. So let's apply Ohm's Law to the power supply question. So we have a 12-volt pump that's rated at 3 amps. Ohm's Law tells us very simply we need the minimum of a 36-watt power supply. So we now know that we need the minimum of a 36-watt power supply. But here's the question: can I have more power supply than I need? And the answer is absolutely yes. In fact, it's usually preferred that the power supply be at least 1.5 times bigger than what you actually calculate on paper using Ohm's Law. Yeah, so it's kind of like your car. It's always better to have a full tank of gas, right? The carburetor only uses the amount of gas, or in our analogy, the amount of current that it needs to work. It never hurts to have a full tank of gas or a larger power supply. So here is a real-world example of Ohm's Law at work, making our shop more safe. So when we first moved into the facility here, within the first month, our lights went out. And so I do have a little bit of electrical background, and so I pull the power panel off. The fuse was not blown, the breaker was not tripped, but the wire going to the breaker that was controlling the circuit of lights was obviously charred, melted, burnt, not a good sign. So that was the problem. So we had no lights, and the wire was melted off the lug on the power panel. So I love to troubleshoot. So the first thing I looked at is, okay, so the wire is kind of melted and charred, which tells me that there was probably too much current going through that wire. And the breaker was not sized properly. I think it was a 20 amp breaker, and it should have been a 15 based on the wire size. Completely another topic. But then I looked at like how many lights were out at that particular time. And then let's put Ohm's law to work. So I counted the number of light fixtures. Each light fixture had 4 light bulbs. These are fluorescent style. Remember, Ohm's law applies to AC just like it does DC. So each light bulb was 40 watts. So it was a simple calculation. 4 times 40 was 160 watts per fixture, and then I multiplied that by times the number of fixtures. So we knew the total wattage of the electrical lighting circuit that had failed. We also knew that the voltage was 120 volts. Remember, Ohm's law applies to AC just like it does to DC. So it was a simple calculation of wattage divided by voltage, and that told us that there was too many lights on the circuit, because the amperage, after we used the equation, the amperage was higher than the wire size could handle, or the breaker size could handle. Remember, I said that they actually had the incorrect breaker in there, which was why it wasn't tripping the breaker. Okay, so the solution was very simple in this scenario. After we repaired the charred wire, we simply did another quick Ohm's law calculation to determine what was the safe number of light bulbs that we could have on this circuit. And then from there it was just going to, I don't know, maybe 6 or 8 of the 4 bulb fixtures, and we removed 2 bulbs out of each fixture, put the cover back on the panel, and it's been working beautiful ever since.